Hi everyone, Professor Lamar here, and welcome to a mini lecture about measurement scales. This mini lecture content is found in chapter 4 of your textbook towards the beginning, so let's go ahead and get started. First, before we jump into the different types of measurement scales, I want you to understand what a measurement scale actually means. Imagine sitting down to construct a survey on a certain topic. You'll come up with questions, and typically if these questions are close-ended, you'll give your participants options to select from. Like for instance, if you ask participants how old they are, you might give them certain options like 18 years old, 19, 20, 21, 22, 23, 24, and so on to select from. Now, those options that you give participants are categorized as one specific type of measurement scale based on how you decided to frame your options. Now, the measurement scales that we create on a survey are very important because they then determine the statistical results that we can run with a set of data. If this currently feels a little abstract, I think things will start to kind of fall into place and click once we talk about our first measurement scale. And that measurement scale is a nominal scale. A nominal measurement scale involves categories that have no numerical values, or in other words, no numbers. So if you ask participants a question and then give them options to choose from, and those options don't have any numbers, that's called a nominal scale. This is often used with categorical variables or variables that have different categories, but those categories don't necessarily mean more or less than anything else. For instance, a good example of this is asking people what their favorite color is. If you ask people what their favorite color is and give them this color wheel to choose from, some people might choose blue, whereas other people choose red, and other people choose green. But one category or one color is not necessarily like more of a color than another color. And so these questions allow participants to choose different categories, which is why it's used with categorical variables, but there's no numerical values or numbers within these different categorical responses. This means that when we have a nominal scale, we can calculate the most frequent response, which is called the mode, but we can't really calculate the average response because it doesn't make sense to calculate the average for a word, right? We calculate averages for numbers. And we also can't really calculate the middle response, which is called the median. Now, this doesn't mean nominal scales are completely useless. Although they do limit the statistical tests we can run, there's still a lot of really useful information that we can gather from nominal scales. And in a few weeks, when you start to construct your surveys for your research projects, we will definitely have some important nominal variables on our surveys, like asking people with which gender or genders they identify, asking people with which ethnicities they identify, and you probably won't ask people their favorite color, but that's just another example. All right, now the next type of scale that we have is called an ordinal scale. Ordinal scales involve rank ordering of something. Now, if you rank order something, that means that you put something in first, second, third, or so on. You might also say you could rank order things by best to worst, or things like that. Basically though, with rank ordering, you know if someone or something is higher than something else or lower than something else, but you don't know by how much. You don't have those precise values. Now this means that you can use the median, the middle value, to report ordinal scales, and also the mode. But the mean is not an appropriate calculation for this. And classic examples of ordinal scales are things like rating scales, like rate the extent to which you agree or disagree with the following statement. I like watching Netflix, or something like that. If someone strongly agrees with that, you know that they experience more agreement than someone who disagrees, right? If someone says that they strongly agree that they enjoy watching Netflix, they clearly enjoy that more than someone who disagrees with that statement. But you don't have a precise number to represent how much more they agree or what that really means. So ordinal scales give us some rank ordering, which means we can kind of say this person agrees the most, this person agrees the least, but we don't have any specific numbers to really categorize what that looks like or create finite distances between the points on the scale. So again, examples would be things like rating scales, rate the extent to which you agree or disagree with this statement, or also things like ranking TV shows from best to worst, or restaurants from best to worst, or things like that. Now, to go into our next measurement scale, we have interval scales. Interval scales have numerical properties that are literal. This means that there's equal intervals or equal distances between points along a scale. What this means is that if you have a 3-point scale, there's the same distance from point 1 to point 2 as there is from point 2 to point 3. There's the same distance between each point on the scale. Now, interval scales, though, don't have a true zero. This is sometimes also called an absolute zero. So let's talk about what this means. A true zero or an absolute zero means that a score of 0 on the scale indicates an absence of that variable. Again, a true zero means that a score of 0 on the scale indicates an absence of that variable. And interval scales don't have a true zero. What this means is that 0 is just another point along the scale, and that point has value. So a classic example of this is temperature in Fahrenheit or Celsius. Think about the temperature scale in Fahrenheit. We know that, for instance, the distance between 40 degrees and 45 degrees is the same distance as between 50 and 55 degrees. It's a difference of 5 degrees. So there's equal intervals or distance for each point along the scale. However, there's no true zero in an interval scale. There's no absolute zero. This means that a score of 0 in temperature is just another point along the scale. And think about what that means. If it's 0 degrees outside, does that imply the absence of temperature? No, it just means it's really, really cold. But a score of 0, like 0 degrees in Fahrenheit, is still a temperature. It doesn't imply the absence of weather, right? And so that means that there's no true zero here. Another classic example of an interval scale is something like test score. With test score, there's the same distance between each point or each percentage ranging from 0 to 100. And a score of 0 on a test is still a test score. A score of 0 doesn't indicate the absence of a test score. So you can see that there are more things and more statistical calculations that we can run with an interval scale, which means that it's pretty useful for our statistical analyses. But the type of measurement scale that has all of the properties that we could need for statistical analyses would be a ratio scale. With a ratio scale, there's equal distances between values on a scale, just like with an interval scale. But a ratio scale also has a true zero. That means that a score of 0 indicates the absence of that variable. Again, the true zero is sometimes called an absolute zero. When we have an absolute zero, we can form ratios with the values. So for instance, if we have it looks like 4 maybe, 4 apples here on the scale, and then on this side, we could put 2 apples there, we would know that the 4 apples weigh twice as much as 2 apples, right? So something like weight can be calculated along a ratio scale. And we could say that 4 apples weigh twice as much as 2 apples, which would be forming a ratio. All right, so ratios do have an absolute zero or a true zero, and we can run mean, median, and modes with this scale as well. All right, so this brings us to the end of our video on measurement scales, and I will see you all for the next one.